Hello, children. Well, today I will be absent due to medical reasons. Okay, what we'll be talking, discuss the new lesson will be vectors and transformation. You will be starting from this small video that I'm sending you. Okay, any questions you have, we will discuss them next week. Okay, in these new lessons, we won't be using the calculator, and it's all about drawings. Okay, so let's start. Chapter 23: Vectors and Transformation. What is a transformation? A transformation is a manipulation of a geometric shape. It can be a square, a triangle, a rectangle, any type of geometric shape. Or a formula. In this case, will be just geometric shapes that maps the shape of its pre-image or original position to an after transformation position. So the idea is that you will have a certain object, can be like this one, for example, and you will perform a transformation, and then you will have another object, okay? Another object. It will be the same object depending on the type of transformation, okay? But the idea is you will have a certain shape, okay, in a 2D plane, in a plane, generally with X and Y axis, and you will use a transformation to move that object that is called the pre-image to the image, okay? Pre-image is before image, okay? So let's continue. A transformation produces an image of the original object in a new position, okay? This is the new position, or different size, because there are transformations that can reduce or enlarge objects. A point P on the object is point P prime of the image. For example, if this is point P, or let's call it A, that's P. Then this point over here will be P prime, okay? So prime represents that you are saying that this point is an image, because it has the symbol prime, okay, of another object that is also called P, this one. So this symbol represents that it's an image of another object, another point with the same name, with the same letter, okay? Here we use this symbol to make the image of the point, okay, to refer to that point. There are different types of transformation. There are reflections, flip or mirror image, a rotation, a turn, an enlargement when you make an object larger or smaller, and a translation when you do a slight movement. You can move it to the left, to the right, up or down, okay? It depends on the vector of the transformation. Okay, what is a reflection, the first step of transformation? First, you have to determine the line of reflection, okay? The line of reflection is called mirror line. Points on the object and the image are the same distance from the mirror line. Distances are perpendicular to the mirror line, okay? So let's say we have this object, this triangle, with point A, B, and C, okay? Now we want to transform this object, this pre-image, to an image, okay? So the first thing it says, we have to know the mirror line. In this case, okay, this one is the mirror line, okay? So points on the objects and the image are the same distance, and distances are perpendicular to the mirror line. So all these are the distances to the mirror line, and these are perpendicular, okay, because you have a 90 degrees angle between these two lines, okay. So how to maintain the same distance of point A to the mirror line? Use a compass, okay. With a compass, you can guarantee the same distance to the mirror line, okay. You mark the sharp part of the compass here. You measure the distance you do a circle, or just not a complete circle, and then you will guarantee that the distance from this point to the other side will be the same that this point to A, okay? Because these are the radius of a circumference, and the radius are always the same. So you mark A prime there. Also with C prime. With B, use a compass, perpendicular straight line, B prime. And once that you have all the image of the objects, what you have to do is simply connect the lines, okay? And now you have the original object and you have the image, okay? And this is how you do a transformation of reflection. These are different rules or properties of the reflection, okay? You can read it. For example, this one says points on the mirror line are their own images and are invariant. For example, point P is at distance 0 from the mirror line, so P prime is in the same place, okay, in the same position. You can read them, okay? So now we'll do this example, okay? We have ABC, okay, and we have to draw a reflection about the mirror line. In this case, they give you a mirror line. But let's practice is in an X and Y axis, okay? I have it here. Let's copy it here. Print screen. Okay. We have, what's happening here? We have this exercise, okay? So let's mark A, B, and C, okay? Let's say, for example, that this is point A, 2, 1 is point A. So point A is 2, 1. Point C, no, B, no. Let's mark it. A is 2, 1. C is 1, 4. And B, let's say, for example, here, B is 5, 3. Okay, these are the points. Okay, what we will do is we will do transformation of these points. You always transform the vertex, okay, of the geometric shapes, and after you have that transformation of the vertex, you will just connect the lines, okay, with straight lines. So let's do a transformation. Let's imagine that the line of reflection in this case is over here. This is the line of reflection. So first, what I know is that all the images of these points have to be perpendicular to the mirror line. Okay, so all these objects, all these point vertices A, B, and C will be moving to the other side. Okay, and at the same distance. For example, if point A is a distance of 3 units from the mirror line, then point A prime will be a distance of 3 units from the mirror line. So this is A prime. Okay. Now C. C is a distance of 1, 2, 3, 4, 5, 6 places from the mirror line. So it will be 1, 2, 3, 4, 5, 6. Okay. The image of point C. And point B will be 1, 2, 3, 4, 5. It's 5 units from the mirror line. So it will be 1, 2, 3, 4, 5 units from the mirror line. Again, we write the primes to represent that these are the images of another points, okay, of the point A, B, and C correspondingly. And we now just connect the lines. And there we have done a reflection of an object, in this case. And this is basically the transformation of reflection, okay? You have to have in consideration the mirror line, and all the distances have to be perpendicular to perpendicular to the mirror line, okay? If we were to draw, for example, say 1, 2, 3, and 1, 2, 3, and this is A prime, then this is not a reflection, okay? Because the distance is not perpendicular to the mirror line. It has to be perpendicular to the mirror line. Let's see what else. Here again, we have to the transformation. In this case, it says draw the mirror line. No, not this one. That is okay. Why I can't copy it? Wait, I'm having technical problems. Let's see, how can I copy this? Here. Okay, we have this one. Again, they tell you to draw the mirror line. We know the mirror line is in the middle between 2 points. Okay, so we just have to select 2 points. For example, these two, the middle is here. These two, the middle is here. These two, the middle is here. So the mirror line will be this one. And how you draw an equation of the mirror line? Since this is a straight line, we have seen that there are different types of lines. There were horizontal and vertical. When you have an horizontal line, the expression was y equals the number. Okay, this is an horizontal straight line. When we had a vertical line, the expression was x equal a, in this case, a certain number. In this case, x equals 4. Okay.